Hi everyone, I am Dr. Leon Raj. Uh, in this video, we are going to see the concrete quality checking using core cutting method. The upcoming lecture 2 and 3 are on concrete quality checking using rebound hammer method and ultrasonic pulse velocity method. Uh, this is the photograph taken at Tawang, Arunachal Pradesh. In view of promoting Northeast tourism, I just posted this photo here. So, need for quality check. Uh, Core testing is the most direct method to determine the compressive strength of concrete in a structure. So, this is a concrete structure comprises of columns, slabs, beams, and foundation. So, cores obtained from the structure to assess whether concrete in new structure complies with the strength based criteria or not, or to evaluate structural capacity of an existing structure. So cores were obtained to assess the new structure that complies with strength based criteria or not, or the structural capacity of the existing structure based on in place concrete strength. In either case, the process of obtaining core specimens and interpreting strength results is often confounded by various factors. The process of core collection, testing, and interpreting results affect the confidence of in place concrete strength. So, the acceptance criteria of concrete at laboratory level is target mean strength. The acceptance criteria of concrete at construction site is in place concrete acceptance criteria as per table 11 of IS 456 2000, uh, that we will be seeing in the coming slides. Then acceptance criteria of concrete core as per IS 456 2000, IS 516 part 4 2018. So this is a concrete core drilling machine. uh, this is the extracted core which exactly looks like this. This is the um, concrete hole. The acceptance criteria of concrete in place. What is meant by in place concrete? Uh, we prepare the concrete at a ready mix batching plant, then we transport it to the site. At site, the concrete which we use for slabs, beams, columns, all those things are named as in situ concrete or in place concrete. The acceptance criteria of in place concrete strength and laboratory level testing and core level are different. Uh, for M15 grade and above, the acceptance criteria for the mean of the group of four non-overlapping consecutive test results in Newton per meter square, which is greater of two criteria, FCK plus 0.825 in the established standard deviation, FCK plus 3 Newton per mm square, whichever is greater, and then individual test results in Newton per mm square, that is FCK minus 3 Newton per mm square. In case of 2 or 3 non-overlapping consecutive test results, then the criteria is FCK plus 4 Newton per mm square, and the individual strength should be minimum of FCK minus 2 Newton per mm square. In case of only one uh, non-overlapping consecutive test results, should be greater than FCK plus 4 Newton per mm square. So the acceptance criteria of in place concrete shall be explained. We will see the acceptance criteria in detail in the coming slides. So this is the three specimens that is 3 specimens equal to 1 sample. So uh, x-axis is compressive strength and y-axis is frequency. This is a probability distribution curve. Uh, how to draw this probability distribution curve using the data points available with you? I explained in the previous video. You can refer my YouTube channel. The link I will post in the description. So this is the target mean strength. This is the target mean strength and this is the characteristic strength. Here the 1 sigma, the 1 sigma is 34.1 percentage of data. That means in this area the data distribution is 34 percentage. In this area that is 34.1%. In this area 13.5% and in this area 2.5%. Here from this point to here it is 1 sigma. The 1 sigma value is 2.5%, but our confidence level is 95%. Therefore the characteristic strength line comes somewhere here, that is our confidence level is 95%. That is 5% of samples can be less than the characteristic strength. So that is nothing but if you are testing 100 samples, only 5 sample can be allowed to be less than the characteristic compressive strength. If you are testing 50 samples, only 2.5 samples. So that is not possible. So 2 samples can be less than the characteristic strength. If you are testing 30 samples, only 1 sample can be less than characteristic strength. If you are testing only 3 samples, none of the sample should be less than the characteristic strength. So that's what this graph is showing. So this is the target mean strength. From here, our acceptance criteria means is somewhere in between this 1 sigma. This is 1 sigma, this is 2 sigma, and this is 3 sigma. Our 1.65 sigma is the 95% confidence level. 0.825 sigma is the in place concrete acceptance criteria. So just note down this. This is in place concrete acceptance criteria. This is characteristic strength. So this is 75% confidence level. Our concrete core strength is 0.85 FCK. That means lesser than this, somewhere here. So that is the acceptance criteria of concrete core strength. If you confuse the characteristic strength, target mean strength, acceptance criteria of in place concrete and core strength, then definitely it ends in big quality control problem. Acceptance of in place concrete. The mean of the group of 4 non-overlapping consecutive test results is equal to FCK plus 0.825 sigma or FCK plus 3 Newton per mm square, whichever is greater. In the absence of established value of standard deviation, values given in table 8, that is assumed standard deviation, is acceptable. For concrete quality up to 30 meter cube, where the number of samples is to be taken is less than 4. So here we discussed about the condition for 4 non-overlapping consecutive test result. In case of less than 4 non-overlapping consecutive test results, then the criteria is FCK plus 4 Newton per mm square, and for individual test results shall be FCK minus 2 Newton per mm square. However, when the number of sample is only 1 as per IS 456 section 15.2.2, the requirements shall be FCK plus 4 Newton per mm square. Here the individual test results criteria is not mentioned. So this is the data collected from the construction site. For our understanding, I am going to explain this whether the collected data is acceptable concrete or not. Whether the concrete is accepted or rejected, that will we will come to a conclusion after evaluation. The date of casting is 27 November 2019, in 28 November 2019 and 29 November 2019. In 27 November 2019, they have collected one sample of 3 specimens. In 28 November 2019, they have collected 2 samples of specimens of 3 specimens, specimen 1, 2, 3 and specimen 1, 2, 3. Here on 29 November 2019, they have collected one sample of 3 specimens. On 27 November, the individual specimen strengths are 23.2, 22.04 and 22.36. Average of 3 specimens of sample 1 is 22.53 MPa. The individual specimen strength of sample 2 are 22.27, 26.13 and 22.4 MPa. Average of these 3 specimens were 23.6 MPa. For sample 3, the individual specimen strengths are 30.13 MPa, 29.73 and 30.53 MPa. The average of 3 specimens were 30.13 MPa. For sample 4, the individual specimen strength is 20.84 MPa, 34.44 MPa and 26.89 MPa. The average of these 3 specimen strength is 27.39 MPa. Now the code specified condition. 4 consecutive samples, non-overlapping means, so here somewhere it is less 22.06, so you cannot put this 34.44 here, so you cannot overlap the samples. So that's what code is saying. 4 non-overlapping consecutive test results. So this is the consecutive test results and non-overlapping test results. So average of this 4 non-overlapping consecutive test result is 25.91 MPa, which is greater than the acceptance criteria 23.5 MPa, which is obtained by, here FCK target characteristic strength is 20 MPa and assumed standard deviation is 4 MPa. Then FCK 20 plus 0.825 into 4, that is equal to 23.5 Newton per mm square. The second criteria is FCK plus 3 that is equal to 23 Newton per mm square. Maximum of these 3 is 23.5 MPa. Individual test result should be greater than FCK minus 3, that is equal to 17 Newton per mm square. So our minimum individual specimen strength should be greater than 17 Newton per mm square, that is 17 MPa. In case of 2 non-overlapping consecutive test results, here is sample 1 and sample 2 and specimen 1, 2, 3 and specimen 1, 2, 3 of sample 1 and 2 respectively. The date of testing were 29 October and 30 October 2019. The individual specimen strengths of sample 1 and sample 2 are mentioned here, that is 24.44 MPa, 23.55 MPa, 21.77 MPa, 26.75, 22.66 and 25.12 MPa. Just take the average of sample 1, 24.44 plus 23.55 plus 21.77 divided by 3. you will get the sample average strength, that is 23.25 MPa. Then again finding the average of sample 2, that is 26.75, 22.66, 25.12 is 24.84 MPa. Average of these two uh, sample strength shall be 24.04 MPa. Here the criteria is acceptance criteria is FCK plus 4, that is equal to 24 Newton per mm square, and individual test results should be greater than FCK minus 2, that is 18 Newton per mm square. Here FCK is characteristic strength 20 MPa. So therefore the minimum individual specimen strength is 18 MPa. In case of only one uh, sample, that is tested in 27 December 2019, the individual compressive strengths are 25.91, 25.02 and 25.78 MPa. The average of these three values shall be 25.57 MPa, which is greater than 24 MPa, that is the only criteria, only acceptance criteria uh, to accept the concrete at in situ or in place concrete. The sampling of in place concrete strength, the quality of concrete in the work from 1 to 5 meter cube of quantity of concrete, the number of samples required shall be 1. From 6 to 15 meter cube of ready mix concrete, ready mix or any type of concrete, minimum number of samples shall be 2. For 16 to 30, minimum number of samples shall be 3. 31 to 50, minimum number of samples shall be 4. From 51 and above, you need 4 plus 1 additional sample for each additional 50 meter cube of concrete. Actually, as per code, this sample collection is negotiable with the supplier. So that was mentioned here. Where concrete is produced is at continuous production unit such as ready mix concrete plant, frequency of sampling may be agreed upon mutually by suppliers and purchasers. Then strength criteria for M20 grade of concrete. Grade designation M20, characteristic compressive strength 20 MPa, target mean strength F dash of CK is equal to FCK plus 1.65 into sigma. Here sigma is standard deviation 4. So target mean strength, that is acceptance level of concrete at laboratory level, F dash of CK is equal to 20 plus 1.65 into 4, that is equal to 26.6 MPa. Then in place acceptance criteria for 4 non-overlapping consecutive samples, FCK at in place, that is equal to 20 plus 0.825 into 4, that is equal to 23.5 MPa, or 20 plus 3, that is equal to 23 MPa, whichever is greater. The greater one is 23.5 MPa. So the acceptance criteria for 4 non-overlapping consecutive samples shall be 23.5 MPa. For 2 or 3 non-overlapping consecutive samples, the acceptance criteria is 24 MPa. Here 20 plus 4, FCK plus 4, that is equal to 24 MPa. The individual specimen strength shall be FCK minus 2, that is equal to 18 MPa. For one non-overlapping consecutive sample, here the acceptance criteria is FCK plus 4, that is equal to 24 MPa. This is the concrete core extraction procedure. There are several YouTube videos are available how to extract core. So the objective of this video is to how to interpret the core test results. So that's why I am giving a picture how the concrete core drilling machine looks like, and what are all its parts and its purpose. So this is the concrete core extracted from the uh, concrete member, and this is a concrete core drilling machine. This is how the drilling bit looks like, and this is a concrete core drilling machine. This is water supply unit, and this is a power supply unit, and here is the anchor bolt, and this anchor bolt holds the machine with this wall, and this four bolts gives a counter action for this anchor bolt, and this is the driving unit which drills the uh, concrete core drilling machine. Then this is how the collected sample looks like. This is the top surface, and this is the bottom surface, that is other end of the core. Usually it looks very uneven, so uh, we cannot test the core with this shape. So we take the core sample and we cut the core sample using concrete core cutting machine. So the concrete core cutting machine either looks like this or this. Then we place the sample here, and using the driving unit we cut the concrete cores, and on the either face um, the surface unevenness will be mm, the surface unevenness shall be minimized to the acceptable level. Then concrete core capping is used to level the concrete cores for testing. So this is the sulfur powder. Uh, this is heating oven and pan. We place this concrete, the sulfur powder over this oven. Then we heat the um, sulfur powder. Then the liquid sulfur will be poured in this capping equipment. Uh, then we place the concrete specimen just like this, and within few seconds it starts setting, and then you can take the specimen out, and on the other direction also you have to do the same procedure. Of course there are several videos are available how to do concrete capping, core drilling, and other related activities. So this is the capped concrete. On the other side is not visible, but this is a capped concrete core specimen. So these are all the other types of concrete capping method. This is gypsum based, and this is neoprene pad and mortar based. There are several other methods for concrete core capping. Of course, sulfur capping is the well accepted and code specified method to test the concrete cores. Once the concrete capping is done, the concrete core looks like this. If you have the neoprene pad, you can place the neoprene pad inside this steel ring and place the concrete core specimen. If you done the sulfur capping, then this kind of rings are not required, so you can directly apply the load like this. Then correction factor and accepted failure pattern. The concrete core of diameter less than 70, the correction factor shall be 1.06. For the diameter of the core 75 plus or minus 5 mm, the correction factor is 1.03. Here the satisfactory failure pattern of concrete core specimen is given here. So only the concrete mid portion, means concrete core's mid portion should subject to any type of failure, that is shear or splitting, whatever it may be the type of failure. It should happen at the mid portion of the specimen, not at the corners. If the concrete cracked like this, or the surface is cracked, or at the edges are cracked, then it comes under the category of unsatisfactory failure pattern of concrete core. Then interpretation of concrete core test results. So we have collected the four concrete core specimens. We named it as 1A, 1B, 1C and 1D. This is core name. Then the length of the core is 199 mm for 1A, for 2B 195 mm, for 1C it is 200 mm, for 1D it is 190 mm. This is the length of the core, and the diameter of the core, 1A is 95 mm, 1B is 94 mm, 1C is 95 mm and 1D is 93 mm. The applied load, that is, once you place the concrete core into the compression testing machine, the applied load shall be 165 kilonewton for 1A, 174 kilonewton for 1B, 179 kilonewton for 1C and 160 kilonewton for 1D. The measured strength F core, that is equal to load by area. Area formula is pi by 4 d square. So load is 165.23 divided by pi by 4 into d square. Here d is 95 mm. So the measured strength is 23.32 MPa for 1A core. For 1B core, the measured strength shall be 25.11 MPa. For 1C, the measured strength is 25.28 MPa, and for measured strength of 1D core is 23.64 MPa. So the formula is F core, that is equal to load by area. This is the load, and using this diameter we find the area. So that is load by area, we get the measured strength. Here the diameter of the core is 95 mm, and we are applying the correction factor, that is equal to 1.03. So here F core D, that is equal to F core into 1.03. So you are multiplying this measured strength into 1.03. So you are getting the values 23.32 into 1.03, that is equal to 24.022. 25.11 into 1.03, you are getting 25.860. 25.28 into 1.03, you are getting 26.041. 23.64 into 1.03, will be getting 24.349 MPa. Now slenderness ratio. Slenderness ratio is equal to length divided by diameter. Here for 1A, length is 199 mm and diameter is 95 mm. So length 199 divided by 95 mm is 2.09, and other values are 2.07, 2.11 and 2.13 for core 1A, 1B, 1C and 1D respectively. The correction factor with respect to slenderness ratio, F is equal to 0.11 n plus 0.78. So if you substitute the n value 2.09, 2.07, 2.11 and 2.13 in this formula, you will get the correction factor. Since the L by D ratio is almost near to, your correction factor is almost near 1. In case of your L by D value is nearly 1, then the correction factor will be less than 1, that means 0.95. So whatever the strength you achieve in the measured strength will reduce. So that's why always take this into consideration. Don't So going slenderness ratio less than 2 is not advisable. As per code, it is allowed, but it is not advisable. Always try to go for strength, um, a slenderness ratio of nearly 2.0. Then equivalent cylinder strength, F equivalent. Here F equivalent is equal to F equivalent cylinder core strength. F equivalent cylinder core strength is equal to F core strength after diameter correction in the slenderness ratio correction. So we are getting the equivalent cylinder strength 24.2, 26.0, 26.3, 24.69 for 1A, 1B, 1C and 1D cores respectively. Then once this equivalent cylinder strength was calculated, equivalent cube strength needs to be calculated. The equivalent cube strength F equivalent Cu for cube, that is equivalent cube compressive strength of core is equal to equivalent cylinder compressive strength of core into 1.25. So you have to just multiply this whole values into 1.25. You will get this value, that is the equivalent cube compressive strength. So 30.34 MPa, 32.59, 32.93, 30.84. So this is the equivalent cube compressive strength. So average of this equivalent cube compressive individual strength shall be 31.68. So the equivalent cube compressive strength of the collected cores is 31.68 MPa. So this is explained with the sample calculation. We have taken sample 1A. The length of the core is 199 mm. The core compressive strength is equal to applied load divided by cross-sectional area. Here the applied load is 165.23 kilonewton. So that's why it is multiplied by 1000. So we convert it into Newton and pi by 4 into d square, that is equal to 23.32 MPa. Then diameter of the core is 95 mm. So the maximum nominal size of aggregate is 20 mm here. So that should be more than 3 times the maximum nominal size of the aggregate. 3 times the nominal size of the aggregate is 60 mm. So the selected diameter of the core is okay. Then corrected compressive strength for diameter, that is equal to 23.32, that we obtained from the load by area formula. 23.32 into 1.03 correction factor, that is equal to 24.022 MPa. The slenderness ratio of the sample 1 is equal to 199 length divided by diameter 95 MPa, 95 mm, that is equal to 2.09. Slenderness ratio is a unitless dimensionless value. Correction factor for slenderness ratio, that is equal to 0.11 n plus 0.78. So here n is 2.09. Once you substitute, you get the value of correction factor F, that is equal to 1.07. Now corrected compressive strength for slenderness ratio is equal to corrected compressive strength for diameter in MPa into correction factor for slenderness ratio. So that is equal to 24.00022 into 1.01, that is equal to 24.272 MPa. The equivalent cube compressive strength in MPa is equal to equivalent cylinder compressive strength into 5 by 4. So you will get 24.272 into 5 by 4, that is equal to 30.34 MPa. Then average cube compressive strength, that is equivalent cube compressive strength 1A, 1B, 1C and 1D in MPa shall be 30.34 plus 32.59 plus 32.93 plus 30.84 divided by 4 is equal to 31.68 MPa. Here the 0.85 times the characteristic strength in MPa is the acceptance criteria of core. So that is equal to 0.85 into 20, that is equal to 17 MPa. And here the acceptance criteria of individual core strength shall be 0.75 times into FCK, that is equal to 0.75 into 20 is equal to 15 MPa. So we are checking the average value, that is 31.68, which is higher than 17 MPa, and the individual values also greater than 15 MPa. Hence, the core sample is accepted. Our doubtfulness on the quality of concrete is rectified using the concrete core testing. So some of the references, IS 456 2000, all the codes like IS 1026 to 2019, specification for mixed design guidelines for concrete. Then Bureau of Indian Standards IS 516 2018 Part 4 for hardened concrete methods of test, Part 4 sampling, preparation and testing of concrete cores. Thank you.